All right, so we're going to move on to lesson 5-4, where we're talking about solving radical equations. Honestly, this should be pretty familiar to you. I mean, there's a little bit that's different, but for the most part, I mean, you've solved a lot of equations, so it should be fairly easy for you. So the first thing that you need to realize is that when we had equations, say, that look like this, like x plus 2, and then we had maybe 3 times that is equal to 4. We always, some of you, want to subtract this 2, but the thing is, you need to get this group, this grouping right here, by itself first. So you would proceed by dividing by 3. So that eliminates the 3 right there, and then you're just left with x plus 2 equals 4/3. And there's no need for the grouping symbol anymore because there's nothing outside that you're wanting to distribute throughout that. These are kind of the same, only the grouping symbol is not a set of parentheses, it's actually just the square root symbol. So we want to get this grouping symbol, which is a square root, together. So we realize that we're adding 5, so we're going to do like we normally do, and we will subtract 5. So now we have square root of x is equal to 13 minus 5, which is 8. Well, how do I get rid of a square root? Well, I think you guys can answer that. You square it, right? Whatever root this is out here, that's the exponent that you're going to use to get rid of it. So if this were a cube root, you would cube it. If this was a fourth root, you would fourth it. All right? So I do that to both sides. And the square and the square root cancel, leaving me with x is equal to 8 squared, which is 64. Now, every now and then, we get an answer that doesn't work, all right? Or it's a, let's say, an inappropriate answer. For instance, it gives us a negative under a square root, and it doesn't equal to the other side. So we always want to check our answer. All right, so what I'm going to do is I'm going to take the 64 and I'm going to plug it in for x. So I've got the square root of, and then I'm going to plug in 64 plus 5. And I want to know, does that equal 13? Well, the square root of 64 is 8. And if I take 8 and I add 5 to it, that does equal 13. So no extraneous solutions here. 64 is a good solution. So now we come over here, we're going to do the same thing. So I want to isolate the square root of x. So I notice that I've got a 3 minus the square root of x. So since 3 is positive, actually, I know a lot of you want to think that it's being added to the x or subtracted from the x, but really the square root of x is being subtracted from the 3. So be careful here. This is a positive 3, so we want to subtract 3. So over here, that leaves me with a negative square root of x. And then 0 minus 3 is negative 3. So before I can actually square to get rid of this square root, I notice that I have a negative out front here that I have to take care of. And remember, this is the same thing as saying like negative 1 times the square root of x. So I'm going to divide by the negative 1. So over here that will cancel. So I have the square root of x is equal to negative 3 divided by negative 1 is positive 3. Then to get rid of the square root, we will square it. And then we have to square this other side too. So square and square root cancel. And I have x is equal to 3 squared, which is 9. So I want to make sure that 9 is a, legit answer. So I'm going to take it and plug it in for the x up here. So I've got 3 minus the square root of, and then I'm going to plug in 9. And I want to know, does that equal 0. So I'm going to put a little question mark here. Well, I know that the square root of 9 is 3, and 3 minus 3 is 0, so my check is good. X equals 9 is definitely not extraneous. So we're going to step it up just a notch, all right? So the thing that I'm wanting to get by itself, let's get our grouping symbol alone first. So that would be everything under the square root. So I notice that I am multiplying that group by 4, and I am adding 3. And if you will recall, we always talk about how to solve an equation. You work the order of operations backwards. Whoop, sorry, guys. So I've got PEMDAS, if you'll remember. So I am multiplying times the group, and I am adding to the group. So if I work backwards, I have to take care of the addition first, and then I can take care of the multiplying. All right, so this will be first, this will be second. So first I'll undo the add. I will subtract 3. So over here that cancels, so I'm left with 4 times the square root of x plus 2 is equal to 19 minus 3, which is 16. All right, now I can take care of that multiplying by 4, so I'll divide by 4. So I've got 4's canceling here, so I'm left with square root of x plus 2. And then 16 divided by 4 is 4. All right, and then I know that you kind of want to subtract 2 at this point, but you can't do that yet because it's still under the square root. So you've got to get rid of the square root first. And to do that, you will square both sides. So now the square and the square root cancel, and on this left-hand side, I've just got x plus 2. Whoa. X plus 2 is equal to 4 squared, which is 16. Then I'm going to subtract the 2, because that's the only thing left over here with the x. So I've got x is equal to 14. So now I need to make sure that 14 is an okay answer. So I'm going to plug into the original equation. So I've got 4 times the square root of, and then I'm going to plug in 14 for that x. So then I have plus 2. And then on the outside I have plus 3. And I want to know, does that equal 19? Well, if I were to just plug this into the calculator, just this left-hand side, it'll just calculate that for me. But since I'm doing this on the screen here, 14 plus 2 is 16. So then I have the square root of 16, which is 4. And then order of operations tells me I've got to multiply first. So 16 plus 3 is 19. So everything is all good. X equals 14. All right, let's take a look at this one. So it's exactly the same pretty much, right? So I want to get the grouping, which would be the square root of x plus 5, all by its lonesome. So the first thing I need to take care of is the minus 1, because that would come first when I go backwards. So I'm going to add 1 to the other side. So now I have 3 square roots of x plus 5 is equal to 11 plus 1, which is 12. Then I can take care of the 3. So I'll divide by 3. So 3's cancel. So I have the square root of x plus 5 is equal to 12 divided by 3, which is 4. Now I've got that root by itself, so before I take care of the 5, I have to get rid of the root. That way it's not in a group anymore. So I'm going to square both sides. The square and square root cancel, and I have x plus 5 equals 4 squared, which is 16. Then I'm going to subtract the 5. So I have x is equal to 11. Alright, and then, so let's plug that into the x up here and check it. So I've got 3 times the square root of, plug 11 in for x, plus 5, and then you've got minus 1. Does that equal 11? Well, you've got 3, and then under the square root, 11 plus 5 is 16. And then the square root of 16 is 4. Then you got minus 1. So I've got 12 minus 1 is 11. So 11 does equal 11. So x equals 11 is a solution. So now we've got a square root on both sides. Now notice that on this side it's just a square root. Nothing is on the outside of the root, and it's the same thing over here. So if I wanted to get rid of this root, I would have to square, and what I do to one side, I have to do to the other side. And what happens on both sides is the square and the square root cancel over here, leaving me with 2x minus 1. And then the square and the square root cancel on this side, leaving me with x plus 4. So now I'm ready just to solve for x. It got rid of both my roots, okay? So I want to get my x's together. This one's smaller than this side, so I'm going to subtract x here. So I have 2x minus 1x is 1x. Then I still have minus 1 on this side is equal to x minus x goes away. This is just 4. Then I'm going to solve for x by adding 1. So x is equal to 5. Now, we would plug this in and check for extraneous solutions, but I think that you've probably got that down. So I want to show you another way to look at something. So grab your calculator, and what we're going to do is we're going to put this side in the y1, and we're going to put this side in the y2 in the calculator. So for this side, we've got the square root of 2x minus 1. On the other side, we've got the square root of x plus 4. And let's go ahead and graph those. So we want to know when they're equal. Alright, and when they're equal is where they cross right there. Okay guys, I'm sure you noticed I put in the wrong number. That's supposed to be a 4. So go back to your y equals, change that to a 4 if you followed me on the screen. Alright, because that's what's in our equation here. So now we'll go back to our graph. This should look better. Much better. Alright, so they cross right there. Now, if you were kind of eyeballing it, I guess you would say it looks like it's 1, 2, 3, 4, 5, comma 3 maybe. Alright. But there's a more accurate way to look at this. So what you're going to do is you're going to press second trace and go to the calculate menu. And then right down here, option 5 is what you want. So you can either arrow down to option 5 for the intersect, or you can press 5. So choose enter. So it's going to come up here at the bottom and say first curve. So that means pick one. And notice that if you look up here at the top, it says sorry, y1 equals the square root of 2x minus 1 in blue. So if you want to arrow over a little bit until you see the little crosshairs come up on your blue line, I prefer to see them so I know I'm in the right spot. Then press enter. Then it'll say, well, what's your second curve? All right, and you see that in red. And notice that you have a little blinky dude on your red curve here. So we say, okay, yes, that's my second curve. And then it'll say, you want me to guess? Well, yeah, I do. So press enter. And right there it tells you the intersection is when x is equal to 5 and y is equal to 3. So if you look, our x was equal to 5. And you could definitely check for an extraneous solution, make sure that that's right, but we just graphed it. We know that it's right. Okay. So we could do the same thing on this one because we have a square root equal to a square root, and there's nothing on the outsides of the square roots. So I'm going to square both sides because that's going to cancel my square roots on both sides. So that leaves me with 4x minus 3 is equal to x plus 9. So now I'm ready just to get everything kind of together. So since this x is smaller than this x, I'm going to move it. So I'll subtract x. So it cancels over here. So I have 4x minus 1x is 3x minus 3 is equal to 9. I want to get this x alone, so I'm going to have to add the 3. So negative 3, positive 3 cancel. So I have 3x is equal to 9 plus 3, which is 12. Then I'll divide by 3. So I get that x is equal to 4. Well, let's put these in our calculator and see how we do. So we've got square root of 4x minus 3. So square root of 4x minus 3. And I'll try to get these in properly the first time. Then we've got the square root of x plus 9. And then we're going to graph that. Okay. So if we were eyeballing, it looks like 1, 2, 3, x is 4 and y is 3, maybe. But let's get an accurate intersect point here. So I'm going to press that way it'll pop up here. All right, so I'm going to go to the calculate menu. So second trace, and I want to choose option 5, which is the intersect. And we're going to go through the same thing. Notice that in here I've got the blue line, but I like to arrow over until I see it pop up there on my blue line. So I've got the blinky thing that says, is this my first curve? I say yes, so press enter. All right, then I get the blinky line on my red curve, and they're saying, is this your second curve? And you're going to say, yes, it is. So press enter. And then it's going to say, would you want me to guess? And I'm going to say, yes. So I press enter. And then it shows me right here that my intersect point is when x equals 4. So if you look at your thing, you did say x equals 4. All right. So now I'm going to throw in a cube root. All right. So if you look, there's nothing outside of your root over here. Everything is under the root. So you need to immediately get rid of this root. Well, if you have a cube root, that means you're going to cube it, both sides. So a cube and a cube root cancel, leaving you with 5x minus 2. And then 12 cubed is 1,728. Now I'm just solving for x. I'm going to add 2. So I get 5x is equal to 1730 divided by 5, and x is equal to 346. And again, you would check to see if you have an extraneous solution. Make sure this solution actually works. But for time's sake, I'm not going to check it, and I already know that it works. All right, so if you look at the second equation we have here, there is nothing outside of your root on this side of the equation. So get rid of that root first. So you have a cube root, so you will cube both sides. Cube and cube root cancel, so you have 2x minus 5 is equal to 3 cubed, which is 27. Then you're going to solve for x. So you've got to add 5. So I have 2x is equal to 27 plus 5, which is 32. Then I'm going to divide by 2. 2's cancel, so x is equal to 32 divided by 2, which is 16. And I would check to make sure that that's, a valid answer, and then I'd move on in life. All right, number 5. This time I've got an x over here, and then I've got the square root of x plus 6 on the right. Well, there is nothing outside of my root on this side, so I want to get rid of the root. So I will square both sides. So the square and square root cancel over here. And then this would just be x squared is equal to, that canceled, so you just have x plus 6. Well, you need to dig back into your brain and think, well, how do I solve for a variable when there is a squared and there is a variable that is just to the first power? And you should be thinking in your mind that you have to factor. So if you're going to factor, you need to move everything over with the x squared if it's the positive one. So x squared is positive here, so I need to move the x, and I need to move the 6. So on this side, I'm just left with 0. On this side, I've got x squared minus x minus 6 is equal to 0. So I'm going to factor this. So minus in the back means you have 1 plus and 1 minus. To get x squared, you have to have x times x. And you need two numbers that will multiply to make this 6 and subtract to make 1. Well, that would be 3 and 2. And since there is a minus sign in the front, the bigger of those two goes with the minus. So you would have 3 here and a 2 right here. So to solve for x, you set them both equal to 0. So then you subtract the 2. So you've got x equals negative 2. And then you've got plus 3, so x equals positive 3. So you have two answer choices here, and if you've figured anything out from what we've done in the past is that a lot of times when you get two answers, one of them usually doesn't work. So we're going to try both of them. So let's plug in negative 2 for the x's. So you've got negative 2 is equal to the square root of negative 2 plus 6. So nothing to do over here. So negative 2 plus 6 is 4, and the square root of 4 is 2. 2 does not equal negative 2. Okay? And if you were to actually graph both sides of that equation, you would see that it actually does not cross in that spot. Now, I know that some of you are thinking, well, the square root of 4 can be a negative 2, but we're not doing that, okay? We're looking for the exact positive root. I didn't have a plus or a minus out here. I'm not looking for a plus or a minus. And I can't have a negative 2 equal to either a 2 or a negative 2. I mean, so you're going with face value here. So this one did not work. So now we're going to try the 3. So I've got 3. And I want to know, is that equal to the square root of 3 plus 6? Well, I know that 3 plus 6 is 9, and the square root of 9 is 3. So the only answer that worked is 3. So this would be your extraneous solution. So if it said, what is the extraneous solution, you would say negative 2. All right? So let's look at another one like that. So this one is kind of set up the same. You've got one side with just an x, another side that has just a root and stuff underneath it, nothing on the outside. So let's go ahead and get rid of the root by squaring. So I've got x squared is equal to square and square root cancel, so I've just got 20 minus x. And again, in your mind you need to think, how do I solve for a variable when there's a term that's squared and then one that is not squared? And that's by factoring. So you need to move the 20, so we'll subtract it. And you also need to add the x and put these in order, right? So that cancels, you just have 0 over here. And then you've got x squared plus x minus 20 equals 0. And I'm ready to factor. So sign them back as a minus, so that means you're going to have a plus and a minus. To get x squared, you need x and x. And what multiplies to make 20 and subtracts to make 1. That would be 5 and 4. And since there's a plus in front, the bigger of those two goes with the plus. Then I'm going to set those two factors equal to 0. And solve for x. So I've got to subtract 5. So I get negative 5. Then I'm going to add the 4. So I get x is equal to 4. So I need to check both of these. Sorry, y'all, if you can hear my children in the background. All right, so I'm going to plug the negative 5 in up here. So I've got negative 5 is equal to the square root of 20 minus negative 5. Make sure you see that you've got a double negative right there. You definitely don't want to mess that up. So I've got negative 5 is equal to 20 plus 5, because that double negative, so that'd be 25. And then the square root of 25 is 5. Remember, we're taking face value here. So that does not work. Then I'm going to try the 4. So you've got 4 is equal to the square root of 20 minus 4. So I've got 4 is equal to the square root of 16. And the square root of 16 is 4. That works. So x equals 4 is my only valid solution. And negative 5 would be my extraneous. All right, so just a couple more. I've got 13 on the outside of the root on this side, and then you've got the square root, and then no roots on this side. So the first thing you need to do is take care of the stuff on the outside, because you want to get this root by itself. So I'm going to subtract the 13. So I have the square root of 5n is equal to negative 10. Then I got to square both sides. And this is super important, especially if you're using a calculator. So I know the square and the square root cancel. But on this side, you have to make sure that you square everything that was on this side. So that would be the negative and the 10. So negative 10 squared is 100. And then you got to divide by the 5. So then you got 100 divided by 5, which is 20. All right, and then you would check to make sure that that was a valid answer. But for time's sake, like I said, I'm just going to tell you that it is. All right. So on this side, again, you want to get this root by itself. So take care of the outside 7 first. So I'm going to subtract 7. So I have the square root of 3n is equal to negative 6. Then I need to square both sides. And again, make sure you put parentheses around the negative if you're going in the calculator. You got to square both the 6 and the negative, okay? So square and square root cancels. So I have 3n is equal to negative 6 squared, which is 36. Then I'm going to divide by 3. So n is equal to 12. And again, you would check to make sure that that's a good solution, but for time's sake, I'm just going to tell you that it is. All right, so the period p in seconds of a pendulum is given by the function p equals 2 pi times the square root of L over 32, where L is the pendulum length in feet, and a pendulum has a period of 4 seconds. Is this pendulum twice as long as a pendulum with a period of 2 seconds? Explain your reasoning. So I don't know if you guys know this, but it's talking about like a clock pendulum, which is like the little thing at the bottom that goes back and forth and back and forth. And so the period of that pendulum is the amount of time that it takes for the pendulum to swing back and forth. All right? So we have a pendulum that has a period of 4 seconds. And then we want to know if it is twice as long as a pendulum with a period of 2 seconds. So we've got to figure out how much each one of them is so that we can figure out if it's double or not. So if you look at this, P represents the period that you have, and L represents the length. And we're wanting to know if the length is twice as long depending on the thing. So let's figure out how long the length is for a pendulum that has a period of 4 seconds. So I would plug the 4 in for P. So I've got 4 is equal to 2 pi times the square root of L divided by 32. So the first thing that I need to do is get this root isolated. Well, I'm being multiplied by 2 pi, so I need to divide by 2 pi. And you guys know me, I don't like to do anything in the calculator until the very end when you're working with problems like this. So I have 4 over 2 pi is equal to the square root of L over 32. So now I've got my root by itself. I can square both sides. And remember, you have 2 things you're squaring over here, a top and a bottom. So make sure that you put parentheses around it. So the square and the square root cancel. So now I've got 4 divided by 2 pi quantity squared is equal to L divided by 32. Well, to solve for L at this point, I'm going to have to multiply by 32. So that gives me a length of 12.97, roughly. 12.97. So the only thing that's going to change is the seconds here, right? So technically we already have an equation. We just need to change the seconds, which was this 4. So I've got 32 times 2 seconds over 2 pi squared. So the length for this one is 3.24. So if I doubled this, that is definitely not 12.97. So the answer would be no, because the length of a pendulum with 4 seconds is 12.97 feet. I know I'm in feet because it tells me that. And a pendulum with a period, or with 2 seconds, is 3.2. All right.